Welcome back everyone. In today's tutorial, we are getting started with the FPAA kit from Okika Devices. First, let's open up the Analog Designer tube. Make sure to install the required USB drivers so your COM port is ready to go. On the hardware side, I have powered up the board with 5 volts and connected to the PC. Let's power on the kit. You will notice that the 4 LED lights up green, which indicates the successful configuration. Let's see how to configure FPAA using Analog Designer. The FPAA chip has 2x2 array of reconfigurable analog blocks, including 4 digital IOs and 7 analog IOs. Let's look at the clock configuration. Here is where the clock is configured. The interface is very basic. You can easily zoom in, zoom out with click and drag option. Let's configure these cells by setting one IO as an input and another one as output. And draw the wire to connect them. On the output IO side, we will attach the DSO and we will place the waveform generator on the input side. You can modify the waveform type with the frequency and amplitude. Let's run the simulation. As you can see, a sine wave is generated. You can easily modify this to any waveform you want. Now let's add a function model from the CAB library. For this example, we will pick an integrator. We will place an integrator inside this cell. Wire it up and start the simulation again. The output now comes as a square wave, which is a result of integrating the sine wave. Let's go back to user manual and try out built-in test circuits. Put the jumper on the J3 header and now reset the board. Now all the FPAA IOs are configured as output and generating a sine wave with different frequencies for each FPAA. 1 kHz, 2 kHz, 4 kHz and 8 kHz. It's always a tradition to start a hardware project with a blinking LED, so let's do exactly. Let me grab an oscillator from the library and it generates sine waveform. We are going to change the clock to generate the pulse at 10 Hz. I am setting the clock input to 1 kHz so that we get the option for much lower frequency values. Let's set it down to 10 Hz. Done. Since our board has 4 FPA, I am going to add another 3 into the project with empty configuration. Now let's download the configuration to the board. As it downloads, a green light shows the upload was successful. Let's verify it with the DSO, and yes, it's generating at 10 Hz. Now connecting to the LED pin. Cool, the LED blink works perfectly. There's a lot more to play around with this FPA kit. Stay tuned for more. Thank you.